So there are various charge distributions. So we are going to calculate what is the electric field intensity at that individual charge distribution. Do you know the various types of charge distributions? What are they? You will be calculating the charge distribution thing. I have told you multiple times. There is point charge. Okay, at a point. Then line charge. Okay, that is on a line. Okay, third on this in a surface. Okay, so that is application. The plane into the plane, that is all comes under the application. Okay, so that first you have to know the charge distributions, that is basics in it. Okay, that is the point charge, line charge, surface charge, as well as what is for three-dimensional volume charge. Okay, so you have to define each one of it. First, charge distribution at various dimensions. Okay, charge distribution at various dimensions. The first is point charge. So how can we define this point charge? How can we define the point charge? From the name itself we can say that. Okay, this is a dimension which is having a charge which is very small compared to the region surrounding it. Okay, so I'm telling you again. A dimension, okay, it is going to be a point. Okay, understand it? A dimension having a charge. Any dimension having a charge which is very small. While comparing to the surface around it or comparing to the region surrounding it, which means there is no charge over there. In the dimension, charge is smaller. Because there is no charge surrounding that region, which means it is not a line, it is not the surface, it is not at all a volume. Okay? It is going to be a very small charge at a single point. Okay, that is the definition for the point charge. How are you going to define the point charge? It is a dimension where the charge is distributed. The distributor, or you can say that the distributed charge is very small comparing to the region surrounding it. Okay, which means already the charge itself very small comparing to the region surrounding it, which means the charge is going to lie in a single point. Okay, so this is said to be point charge. If you take this point as P, means this charge can be either positive, or if I am taking the point as Q, means this charge. So charge will be getting confused. Okay. So if I am taking this point as P1 means the charge can also be either positive. If I am taking another point that is P2 means the charge can either be negative also. So in a point charge it can either be positive or can be negative. Okay. How we are going to define the point charge? In the dimension, the distribution of charges very small compared to the region surrounding it, which means the charge is occupied only the point. Okay, the charge can either be negative or positive. Okay, the charge can either be negative or positive. For example, I have taken 2 points here. That is point 1 P1, other point is P2. So I have told you the charge can either be positive or negative. Either P1 carries the positive charge or negative charge. Like this P2 carries the positive charge or negative charge. These are the 2 options. Okay. So put on the heading is next is line charge. Okay. So what is line charge then? In a dimension, the charge is going to be evenly spread. Okay. The charges are, we can say that the charge is evenly distributed in a line. Okay. The charge is evenly distributed in a line. If I am taking a line, okay, the third line or else a straight line. Okay. So the charge can either be positive or negative. If I am taking curved line, throughout the line it is going to be positively charged. Okay. So if we make one more curved line, that is the charge can either be positive or negative, but a single line will carry the single charge. That is, if this line is carrying positive charge, means throughout the line it will carry only the positive charge. If the other line carries the float a line, it will carry only the negative charge. It can be either a curved line or either it can be a straight line. Okay. So if I am saying this line is carrying only the positive charge, I am saying this line is carrying the negative charge. Can you tell me an example for this? Capacitor. A parallel plate capacitor is an example for this. Okay. So one more thing. The line can either be, can also be, this is what? What is this? We can say it is a closed line. That's it. We can say that it is a closed line. This can also be carrying the positive charge. If this closed line is carrying the positive charge, throughout the line it will carry the positive charge. Okay. So the line can be a curved line, or it can be a straight line, or it can be a closed line. Clear? So that is all about line charge. So the next is surface charge. So surface charge means these both will comes under. This is just a point charge of any dimension. Okay. So here it is one dimension. Okay. So surface charge will comes under. Surface charge we can say that as two dimension, right? So the next is surface charge. So I'm taking a surface. Okay. So the surface, throughout its two-dimensional surface, it will carry the same charge. If this surface is carrying the positive charge, one more surface can carry the negative charge. Okay, how can we define the surface charge? Surface are how can we define it? In a two-dimensional surface, the charge is distributed evenly. Okay, so for that you can draw this diagram and explain. Okay, so now next, how can be a volume charge? Three-dimensional. It can be either a cylinder. Okay, for example. Okay, so which means if I am taking a cylinder, so if this cylinder carries the positive charge, throughout the three cylinder it will carry the positive charge. Okay, so now everything I am saying, either a dimension, one dimension, two dimension, three dimension, everything is having some charges, right? So how can we define it? In terms of charge density. Okay, how can we define the how it is carrying the charge? Every charge is carrying how many how can we say that? We can say it as charge density. Okay, do you remember the notations for charge density? How can it be denoted? Charge density is denoted as for point charge. There could be any because in point the charge is going to be just positive q, negative q alone. Okay, so charge density will start from the line charge. Line charge, surface charge, and for volume charge. Okay, how can we take charge density? How can we define it? For a line charge density, how can we define it? Line charge density. Yes. Line charge density. You can easily define it. Density means what? Q by U. What does the U means? Q is the charge. Okay, so let me tell you. Okay. Charge density is defined as the ratio of charge per unit length. Okay, for unit length, our meter length, எவ்வளவு charge இருக்கு அப்படிங்கறத நான் ஃபைண்ட் அவுட் பண்ணனா I can able to define what charge density. Which means density means what can we say that population density னா என்ன சொல்லுவோம்? ஒரு குறிப்பிட்ட ஸ்கொயர் கிலோமீட்டர்ல ஒரு குறிப்பிட்ட ஸ்கொயர் மீட்டர்ல எவ்வளவு I mean per length. Total charge per unit length. Okay. So after defining that, we have to say that charge density is denoted by the letter rho. Since this line charge density is denoted by the letter rho L. So that is equal to charge per unit length. Now you know it. So charge is denoted by the letter Q divided by unit length, which is meter. This is for line charge density. Clear up to this? And the next is surface charge density. So how can you define the surface charge density? Surface charge density. It is defined as, here it is occupied charge in a line, right? Here it is defined as a ratio of total charge in the surface per, here it is what? Per length in meter square. Okay. So that is, so it will be meter square means area. That's it. Okay. That is total area in meter square. Okay. So we can define surface charge density means rho. Surface charge density means rho surface. Yes. It is defined as the ratio of total charge in coulomb. It is defined as the ratio of, you should write in the wordings also. After that only you should write the formula. That is why it takes repeating it multiple times. Okay. So total charge in coulomb divided by total, sorry, unit area in meter square. Per unit area in meter square. Clear? That is, surface charge density is defined as a ratio of total charge in coulomb per unit area in meter square. You know that unit of area is meter square. So, can you able to follow me? The next is volume charge density. How can you define the volume charge density then? Volume charge density can be defined as total charge per volume. Total charge by volume. Total charge in coulomb per unit volume. In volume will be unit as meter cube. That's it. Okay. So surface charge density. Sorry. Volume charge density is defined as random. Volume charge density is defined as the ratio of total charge. So volume charge will be denoted by the letter rho suffix V. Okay. So that is equal to total charge in coulomb divided by unit volume in meter cube. So now you can define the unit by itself. What is the unit for line charge density? Coulomb per meter. What is the unit for surface charge density? Coulomb per meter square. What is the unit for volume charge density now? Coulomb per meter cube. That's it. Okay. So, next what we are going to find out means, we are going to find out that, I am saying that total charge in the line, total charge in the surface, total charge in the volume we are saying, right? So, how can we find that charge? The charge brings later, we need to find it out. So, to find, put in the ideas, finding the charge Q with rho L. If I know the charge density, I should find out the charge. How can we find out that? Okay. So that is when we need to find out this. If the rho L, okay. If the then surface charge density is given as, we know 3 coordinate system. What is it? You can say that either x, or it may be in the y, or it may be in the z. We don't know where is our point, where is our line, or where is our surface or volume. We don't know that. Okay. So if it is denoted as rho L is 3, it is given as 3x. Okay. So which means somewhere in the x-axis the surface is going to be. Okay. So or else it is given as rho L is 4y. Somewhere in the y-axis or observation or the surface or volume or line is going to be. Okay. It can be like this also. 4y square, 3x square. Anyhow, it is going to be in that particular coordinate. Okay. If it is given like this, rho L becomes to know. Okay. So then, how can we find out the charge? Okay. How can we find out that means by differential method. So to find out the charge Q, when we know the rho L, we are going for differential method. Okay. So for line charge, how can we find out the? In physics we have studied a long straight wire with we will be considering a small length. What is that small length? DL. We have taken that small l as DL. Differential length, which means you might take some length for observation, we might be taking some length of observation. That is why that is DL. Okay. So now charge also what we are going to do? dq. That is also we don't know. It might be differential of charge q will be equal to what we know. We know the charge density in the line rho L. It is given in the coordinate where it lies. Okay, so we know that rho L and what is there? For observation, I have taken the length dl. So dq is equal to rho L into dl. So how can we find out the q now then? By taking integral. Okay, so integrating on both sides, what can we do? Q is equal to integral of dq, right? If I take integral of dq is what? Q. That will be equal to, here also we are going to integrate, right? Integral of rho L dl. Can you able to understand it? How we are calculating the charge in a line, in a infinite line or in a specified line. If we need to find out the charge, I will be taking a small length as reference. That length is to be measured here, said as dl. I know the surface, line charge density, that is rho L. It is given it is I know where it lies, x axis or y axis, and in the three coordinates where it lies I know. That is, it is given as rho L is equal to 3x square or 4y square, something like this. Okay. If it comes to know like this, what I have to do? I have to integrate like this. Okay. So that is the formula for finding out the line charge density. Using line charge density, finding out the charge Q. Clear? So this next for this surface, the same case rho L. In case of surface, what it is? Rho S. If I come to know the rho S, okay, I need to find out the charge Q. How can I find out? The same method. Okay, finding Q with what I know now? Rho S I know. Okay, so you can write the same method. Finding the charge Q with rho S. Okay, here is also what? Differential of charge Q will be equal to here rho S into line the small length is dl means here in surface it will be ds. So ds. Okay, so if I am taking integral on both sides, so I can get q which is the integral of dq, that will be equal to integral of rho S ds. Okay, this is the method to find out the charge if we know the surface charge density. Clear? Can you able to follow me now? And one more thing I told you to further that. So here I am integrating the line, right? In line, one more cases I have told you. The line can be either a curved line or it can be a straight line with some parallel capacitor. One more is what? Closed line. So if it is a closed line means what we have to do in integral? Closed integral. That's it. Okay. So you have to write down if the line is the closed line. So what we have to do? Q is equal to closed integral of dq is equal to closed integral of rho l dl. Clear up to this? Next, the same for volume method of finding the charge q with rho suffix v becomes known. How can we find out for volume? Everything will change with respect to rho v. That is dq is equal to rho suffix v into here the small area will be small space will be volume. So we will be differentiating with respect to v. Okay. So if we take integral of the dq, will be getting the rho v into dv. Clear up to this? That is how the charge distribution of point charge, line charge, surface charge and volume charge, and we are finding the charge at these four charge distribution system. Clear? Everyone clear up to this? The next, after writing this, put the heading as electric field intensity. Electric field intensity due to infinite line charge. Electric field intensity due to infinite line charge. Shall I write the first part? Shall I write this? Okay. For electric field intensity due to infinite line charge. So I have taken an infinite line. Okay. So and then in the infinite line I am considering a small reference line. That should be considered as dl. So that is considered as dl. And its charge density is rho l. Okay. So that is along z axis. And this is going to be the x axis. And where I am going to find the electric field, okay, that is along the y axis. Okay, that is along the y axis. So this is the line where I am going to find the electric field over a point P. The point P is lies in the y axis. Okay, so now what are the representation we have to take means this is the smallest area we are going to consider. Okay, so here is my point where I need to know the electric field. How much the electric intensity is. The angle between this, okay, with respect to the object was taken as theta. Okay, and its unit vector is taken as A or vector. Okay, after that, the distance of the point P from the object is taken as small r. Okay, the distance of this all you have to write one by one in points. Okay, first what we have to say. That for infinite line we are considering the infinite line is along the z axis. Okay, the small area in the line we are considering for reference that is taken as dl. Okay, and the point where I am going to find the electric field intensity is along the y axis, and the considered length dl to the point P with respect to the origin O, its angle is what? Theta. Okay, after that the point P where I am considering the y axis from origin, the distance is r. Okay, so and the line that is carrying the charge density that is rho l. Okay, and the unit vector that is traveling along for everything we are making unit vector as reference, okay, which is very very small. So it's a told you for in the topic important observations of electric field intensity. Clear? Electric field intensity of a particular point and I should take the unit vector as reference. Okay, the unit vector which we are taking that reference should be very small. Okay, so that is considered as AR vector. Clear up to this diagram? and this is the electric field. The electric field traveling along the y-axis will be taken as, we don't know it till. So it is d of dy. Okay. Likewise, along the x-axis means it will be dEx. Okay. So that is what we have considered. The total electric field. Okay. That is the here. That is the vector sum. Here it is dE vector. Clear? Clear up to this? And now we know that what we know dq is equal to, we have already seen, if I line charge, if I know the rho L, I need to find out the charge q means what will be doing? We will be going for the differential method. So I know this formula, that is dq is equal to rho L into dl. Clear? The dl is in which axis? Z axis. So I can write that as dz. Clear? So rho L into dz. Clear? Now you need to specify the coordinates of each. Now the coordinates of dq are dq, where the charge will be over here, right? In the line. So that is along which axis? Z axis. In x there is no charge. In y there is no charge. So that is going to be 0, 0. X0, Y0 for Z is represented as Z. Okay, and the coordinates of the P are, for the P is from the object O along which axis? Y axis. For X there is no point, so it is 0. For Y the distances are from origin, Y axis distances R, and Z there is no point P, so it is 0. Clear up to this? Next what we are going to do, that is we need to find out the R vector. Okay, so that is R vector. What it is? R vector is equal to addition of two vectors, where we have already seen yesterday. Okay, what is the distance formula in terms of vector? We have studied in mathematics. Distance formula in vector form. That is x2 minus x1. We have studied distance formula in vector form. In 12th maths we will be studying that. Okay, that is it will be like this. Two vectors are there. Okay, so if this is x1, x2. Here I am taking this r means what is the distance of this particular? We will be calculating this as x2 minus. Yesterday I told, right? The distance between these two. Clear? That is distance formula in the for the vector form. That is x2 minus x1. So the distance vector or vector can be, this is the formula of x2 minus x1. Here what is x2? The distance of r to the point P. That is I am taking it as r suffix P. Minus the next vector where it is the distance of from origin O to the point to the considered length dl. That should be taken as r suffix dl. From origin to point P, we can take it as r suffix P. From the origin to the considered reference length, we have taken dl, take it as r suffix dl. So, what is the distance between these two now? The distance r vector will be rp minus rdl. Can you able to follow me? This is the distance formula in vector form. x2 minus x1. Where x2 is here rp. x1 is here rdl. So, the distance vector r vector can be rp minus rdl. That is equal to rp is where the distance r with respect to which axis? Y axis. So, unit vector will be a y vector. So, distance r into a y vector. Clear? And for rdl. For rdl where it is? This is the z line. Okay. So, it will be taken as z into, it cannot be same way. If we take this as r means, it should be taken in another notation. Clear? Because the point P from the origin cannot be equal as from the point dl from the origin. It might be equal, but we can't predict whether it is equal. Now, equal to confirm a solution, we can take both as r, but it is not known. So, take it as different notation. Now, we need the notation is z axis, so we can take that as z. The unit vector is a suffix z vector. Can you able to understand what I am saying? So now, that is It is a vector now. The magnitude of vector means root of the coefficients. Root of the algebraic sum of the coefficients. That is the formula. Remember the magnitude formula. Whenever I am taking if it is the equation is ax plus by plus c means what is the magnitude of it? Root of x coefficient a square plus b square plus c square. That formula magnitude of r vector is equal to root of the coefficient of a by square r square plus root of the coefficient a z is minus z the whole square is what? Plus z square. So the root of r square plus z square. Clear up to this? Next, unit vector. What is the unit vector formula yesterday I told you? Vector divided by magnitude of the vector. What is the vector here? R vector. That is r a vector minus z a z vector. Divided by its magnitude. What we will calculate? Root of r square plus z square. Okay. Now next what you want to know? Electric field intensity. What is the formula for electric field intensity? Yesterday we have seen E vector is equal to. Shall I write this diagram? Shall I write this diagram? So now, what is electric field intensity formula? Yesterday I told you. E vector is equal to for a unit point charge. What it is? Q divided by 4 pi epsilon naught r square. Right? Here, this electric field is specified here. It is taken as dE. Right? In the diagram, if you note that it is taken as dE. The electric field at the point is taken as dE. So dE will be equal to, is the charge specified here? No. Then it should be taken as dQ divided by what it is? 4 pi. We can write that we know that electric field intensity formula E vector is equal to Q divided by 4 pi epsilon naught r square along with the unit vector. This is the known formula yesterday we have seen it. And now with respect to our application, it is V is equal to dQ divided by 4 pi epsilon naught r square. What is our r here? What is the distance? The curved distance which is taken as r vector, right? So the distance here is capital R square into unit vector is ar vector. Clear up to this? Now we can write it. D vector is equal to dQ divided by 4 pi epsilon naught r square into what we have found for a vector? R a y vector minus z a z vector divided by root of r square plus z square. Clear up to this? Now for the calculation purpose, one thing we are going to consider. Okay, so let us, I am going to consider if d vector is equal to dQ divided by 4 pi epsilon naught r square. What I am going to do is, I am going to take square root of this, that is root of r square plus z square the whole square. Okay, along with that r into a y vector minus z a z vector divided by root of r square plus z square. Okay, what is r here? The magnitude of r is, if the r vector देखो मैंने लिखा distance can be founded by square of the, here I have found it, right? R vector's magnitude is what? Root of r square plus z square. That thing I am going to substitute over here. For r it is root of r square plus z square. What is here? The whole square. Clear? So right. So sorry. Okay, 4 by epsilon naught into root of r square plus z square the whole square. Clear? Up to this. The next it is dQ divided by 4 pi epsilon naught. How can we write these two both? R square root of r square plus z square. Can you able to follow me? Cancel it. Okay. So if your root and square cancel means what will be here? R square plus Z square will be here. Okay. So here it is going to be R A vector minus Z A Z vector all divided by, we can write this as R square plus Z square the whole power 1 by 2. A power m into A power n formula. It will be A power m plus n. Am I right? So we can add this powers. Power if we add it, we will be getting P vector is equal to PQ by 4 pi epsilon naught. In the numerator it is R A y vector minus Z A Z vector. The denominator it will be R square plus Z square. The whole power 1 by 2. 1 plus 1 by 2 it will become 3 by 2. Clear up to this? Now, the infinite plane sheet line is along this. Look at your diagram. Look at your diagram and tell me the infinite line is along the z axis. What is the upper limit? What is the lower limit? I am going to integrate this. Okay. Integrating. To integrate this, can I find out the electric field intensity, right? So I am going to integrate this. While I am integrating with respect to what? Since it is lies in the z axis, the upper limit is, the lower limit is from minus infinite to plus infinite. Have you noted that in your diagram? The infinite line is where along the z axis, its lower limit is minus infinite and its upper limit, it is infinite line, right? Minus infinite to plus infinite. So, if I am integrating, it will be written as E vector is equal to E vector will be equal to integral of, what is the lower limit? Minus infinite to plus infinite dq divided by 4 pi epsilon naught of R square plus Z square or Ay vector minus Z Az vector. Clear up to this? And now, what? Okay, power previous. Now what we are going to do? We are going to integrate it. It is in the line is in the z axis, so the upper limit is infinite to the lower minus infinite. So integral of this integral of B vector is equal to E electric field intensity E vector, that is equal to integral of minus infinite to plus infinite. The remaining time dq divided by 4 pi epsilon naught R square plus Z square the whole power 3 by 2 R A vector minus Z vector. So far it is continuing. Okay. So now we are going to consider that. While considering the distance r from the point to the point P from the origin pole, okay. At the same time, in the diagram you will see that the DL where we have considered the length from it is small, right? Origin la irundhu DL irukra distance compare பண்ணும்போது அதோட origin la irundhu point P இந்த ரெண்டு distance compare பண்ணும்போது who is small, z is small. Okay. So we are considering that z is small, the distance of origin to the DL distances. If we consider that as very small, we can able to neglect this step. Clear? When saying if z is considered very small, then that can be neglected. Okay. Next, what we are doing, we know that line charge density dq. The charge to find out dq is equal to what we know? Basics that is rho L into dz. Okay, so here rho L into dl actually in the first itself we have taken that dl as dz. Clear? So now E vector can be integral of minus infinite to plus infinite. Instead of dq, what can we write? Rho L into I have written here dz. But the case is dq is rho L dz. Okay, there r into ay has written it like r into dy. Just எல்லாமே multiplication இருக்கிறதுனால தனியா செப்பரேட்டா எழுதிருக்காங்க. Everything is in multiplication mode. Denominator 4 pi epsilon naught remains the same as per the whole power 3 by 2. Clear? This rho L dz is the formula for dq, and this r a by is already there. Continuing, and we have considered that this distance is very small, so it is neglected. Can you able to follow each step? Next what we have to do for we are applying. If z is minus infinite, what the case? If the z is plus infinite. Consider what if z is minus infinite. We have taken tangent. Okay, tan theta. So that is theta is equal to tan inverse of. That is for infinite what? Infinite equal to tan theta. If you consider that theta equal to tan inverse of minus infinite. When it will be minus infinite? At pi by 2 minus, since it is a minus pi by 2, that is minus pi by 2 means minus 90 degree, and for upper limit theta will be tan inverse of plus infinite, which is pi by 2, that is 90 degree. So the limit varies from, now we have found out, okay, for that angle calculation only this diagram. Okay, so after that we know where it is. Now we have substituted that E vector is equal to minus 90 degree to plus 90 degree. Okay. Why we are going for this diagram means we have taken minus infinite lower limit to upper limit. எது எடுத்தாலுமே ரெண்டுமே என்னதான் ஈக்குவல் தான், because it is equal and just what opposite. ஒரு பக்கம் எடுத்துக்கிற லைன் வந்து dl னா எடுத்தேன் அப்படினா if it is plus ஆ இருக்கும், அப்படி இல்லனா the negative axis ல minus ஆ இருக்கும். The length are equal but in opposite. That is what. Now Z1 ன்னு எடுத்துக்கிற place பண்றேன். இது Z2 ன்னு எடுத்துக்கிட்டேன் அப்படினா electric field Z1 will be equal to electric field Z2. Equal but எப்படி இருக்கும் and opposite. Okay. Plus infinite minus infinite க்கு அது வந்து vary ஆகும். அந்த infinite இப்ப நம்ம என்ன find out பண்ணியாச்சு, minus 90 degree to plus 90 degree we have found out now. That is equal to rho L by 4 pi epsilon naught. Now we are going for a formula that z is equal to r into the distance is there for z, that is from origin to towards the electric field. The E is electric field point P is what distance? R into what is the angle there? Theta. So z will be equal to r into tan theta. So by that we can write that r is equal to z by tan theta, and here is a tan dz. So I am going to differentiate it dz. So z can be differentiated, it will be like dz. Dz will be equal to r, we can't do that because it is distance, right? It is constant. So r will be, okay, if you differentiate tan theta, it will be secant square theta d theta. Okay, and now we are going to substitute these things in the formula. That is r square plus, in place of z square what can we substitute? Z is r tan theta means z square is r square tan square theta. The r is going to be remain, and in place of dz what can we substitute? R into secant square theta d theta, and the a by term is continuity. Clear up to this? Next, after applying the limit, okay, now what we are going to do? Who is constant here? Rho L will be constant. 4 pi epsilon will be constant. Okay, r also will be constant. Only for where we are applying this upper limit, lower limit, only for the theta. After applying this upper limit and lower limit, we will be getting the electric field in an infinite line. It will be as rho L by 2 pi epsilon naught into r a by vector. Okay, so this we are considering for r vector or distance, right? So the unit vector can be replaced by r vector. That's it. Clear up to this? Just no need to just apply this upper limit, lower limit. You can just remember this also. Okay, if you want to apply, you can do that also. Okay, after applying this lower limit or upper limit, we will be getting the electric field intensity as rho L by 2 pi epsilon naught r into a by d vector is continuity. If the unit vector is a r d vector, it is replaced with the a r d vector. A r vector. Clear? That is all about electric field intensity to be an infinite line charge. Any doubts so far? Here at boy side.